Okay, so another example to connect particles. A light scale pan is attached to a vertical light inextensible string. The pan carries two masses, A, which is 400 grams, B is 600 grams as shown. And then the pan is raised vertically using the string with acceleration 0.5 meters per second squared. And we're going to find the tension in the string. We're going to find the force exerted on B by A and the force exerted on B by the pan. Okay, so if we label some forces on here, the tension is what's pulling up this object. Mass of the whole system is the mass of both of these combined, which is 1 kilogram. So therefore its weight is G. Therefore, it's quite a simple equation we've got here. It's going to be T subtract G is equal to 1 times the acceleration. And that's 0.5, so T is 0.5 plus G, or 10.3 newtons. Part B, we're going to find the force exerted on B by A. So to work that out, what we're actually going to do is work out the force exerted on A by B. It seems a little bit strange, but it's all to do Newton's third law. So the idea is that those forces are equal and opposite. So if we work out the force on A by B, it's the same thing. So if we consider A, it's 400 grams. The forces on it are going to be its own weight. Because it's 400 grams rather than kilograms, that's 0.4 for its mass times G. And then we've got a force from B, which I'm going to call R as a reaction force. And both the only forces actually acting on A. We know it's accelerating upwards at 0.5 meters per second squared. So if we resolve vertically on A, R subtract 0.4 G is the mass, which is 0.4, times the acceleration, which is 0.5. So we can then resolve to get R is, that's 0.2 add 0.4 G, and we will just calculate what that is, which is 4.12 newtons. And we can do something similar for part C. We're going to find the force exerted on B by the pan. Well, we can do the same kind of logic as in the previous question. We're going to get the force from the pan on B. So on B, we've got various forces. So we've got actually the force we worked out from before, which is 4.12. We've got its own weight, which is going to be 0.6 G. Then upwards is the force from the pan, which I'm just going to call P, because I already used R for reaction force a moment ago. And it's accelerating upwards at 0.5 meters per second squared. So P subtract 4.12 subtract 0.6 G will be equal to the 0.6 for its mass times 0.5. And again, we can just solve that to find what P is. Which comes to 10.3 newtons. And there we have it.